Everyone, today we'll be discussing about trigonometric substitution. The method of trigonometric substitution can be very effective in dealing with integrals when the integrand contains the expressions a squared minus u squared, a squared plus u squared, and u squared minus a squared. The three basic substitutions are when the integrand involves a squared minus u squared, we try u is equal to a sine theta. When the integrand involves a squared plus u squared, we try u is equal to a tangent theta. And when the integrand involves u squared minus a squared, we try u is equal to a secant theta. Let us say, for example, that we want to evaluate x cubed dx over 4 minus x squared. The term that makes it difficult to integrate is 4 minus x squared. 4 minus x squared is of the form a squared minus u squared, where a squared is 4 and u squared is x squared. Here we can compute for a equal to 2 and u equal to x. With this, it is advisable to use u is equal to a sine theta. Thus, we use x is equal to 2 sine theta and its derivative is dx equal to 2 cosine theta d theta. If we are going to apply substitution of x is equal to 2 sine theta, x cubed would be 2 sine theta cubed, and that would be 8 sine cubed theta, while dx is 2 cosine theta d theta, and the denominator square root of 4 minus x 2 sine theta quantity squared. So that would be 4 sine squared theta. This would give us 8 times 2 equal to 16 sine cube theta cosine theta d theta all over 4 times the quantity 1 minus sine squared theta. Take into consideration that your 1 minus sine squared theta is equal to cosine squared theta. Taking the square root of 4, that would be 2. And taking the square root of cosine squared theta, we have cosine theta. We can cancel out cosine theta to cosine theta, and 16 to 2, so that would be 8. The numerator would now be sine cubed theta d theta. Factoring out sine squared theta, we have sine squared theta times sine theta d theta. We have to convert this as a function of cosine. Since your du is a sine theta d theta, your u must be a function of cosine theta. So we find an identity for sine squared theta, and that is 1 minus cosine squared theta. This is now of the form 1 minus u squared du. So your du is sine theta d theta, and u squared du would be your cosine squared theta sine theta d theta. The integral of sine theta d theta is negative cosine theta, and the integral of u squared du is u cubed over 3. With this, we have negative 8 cosine theta plus 8 over 3 cosine cubed theta plus c. Taking into consideration your sine theta equal to x over 2, so our sine theta is equal to x over 2, so your sine of theta is opposite x over the hypotenuse 2. This would give us the third side, so we have adjacent squared plus opposite squared equal to the hypotenuse squared. So the adjacent side squared is equal to h squared minus o squared. That is 2 squared minus x squared. So that is 4 squared minus x squared. So a is equal to the square root of 4 minus x squared. Since we will be needing cosine theta, so cosine theta is adjacent over hypotenuse. So that is square root of 4 minus x squared over 2, over 2. Sorry. So that would be square root of 4 minus x squared over 2. So plugging it in, so we have cosine theta is square root of 4 minus x squared over 2 and square root of 4 minus x squared over 2. And thus, for our final answer, applying some simplification, 8 over 2 is 4 and raised to 3 and then square root, so that would be raised to 3 over 2. For our second problem, let us consider the integral of dx over 4x squared plus 9 quantity squared. So this 4x squared plus 9 squared, so 4x squared plus 9 is your u squared plus a squared. If that is your expression, u squared plus a squared, your u squared is 4x squared and your a squared is 9. So taking the square root, so a is 3 and u is 2x. Since we have an a squared plus u squared or u squared plus a squared, it is suggested that we use u is equal to a tangent of theta. U is 2x and a is 3. So we have 2x is equal to 3 tangent of theta. Your x is also equal to 3 over 2 tangent of theta. That is why your derivative dx or your differential dx is equal to 3 over 2 secant squared theta d theta. With these two expressions, we can now plug it into the original expression. So dx is 3 over 2 secant squared theta d theta, 4 times x. So 4 times 3 over 2 tangent theta squared plus 9. So we have 9 tangent squared theta plus 9 squared. So we can factor out 9. So that would be tangent squared theta plus 1. And take note that secant squared theta is equal to tangent squared theta plus 1. So this expression here is the same as secant squared theta. So we have here 9 squared, which is 81, which we will be factoring out from the expression. And this is equal to secant squared theta. So secant squared theta is secant to the fourth. But we will be canceling out this secant squared theta with one of the secant squared theta. So we have 1 over 54 integral of d theta over secant squared theta. So we have, so this is 81 and 3, which is 1 over 27. 27 times 2, 54. So we now have 1 over 54 integral of cosine squared theta. And we will be using the power reducing formula cosine squared theta is equal to 1/2 of 1 plus cosine 2 theta. So 1 over 54, we factor out 1/2 and then we have 1 plus cosine 2 theta. 1 over 54 times 1/2 is 1 over 108 integral of d theta. 1 over 108 integral of cosine 2 theta d theta. So we have to apply a correction factor of 2 and we neutralize it by 2 as well. So we have 1 over 108 theta. The integral of d theta is theta. The integral of d theta is theta. And 1 over 108 times 2. So 1 over 216 integral of cosine 2 theta 2 d theta is sine 2 theta plus c. So we have 1 over 108 theta plus 1 over 216 and then sine 2 theta. Sine 2 theta is 2 sine theta cosine theta. Now we go back to the original triangle. 2x is equal to 3 tangent theta, and tangent theta there is 2x over 3. Tangent is opposite over adjacent. The opposite side would be 2x and the adjacent side would be 3. The hypotenuse would now be, this is wrong. So the hypotenuse would be square root of 2x quantity squared plus 3 squared. So square root of 4x squared plus 9. With that, we have tangent theta is equal to 2x over 3. So theta is inverse tangent of 2x over 3. So 1 over 108. Theta is arctangent of 2x over 3. And then we have 2 and 216 would cancel out as 1 over 108. Sine theta is opposite 2x over hypotenuse. So 2x over square root of 4x squared plus 9. And cosine theta is adjacent over hypotenuse plus c. So we now have 1 over 108 arctangent of 2x over 3 plus, so we cancel out 2 times 3 is 6 to 108. So 108 divided by 6 is 18. That's why we have 1 over 18. And then for the numerator, we have x. And then for the denominator, we have 4x squared plus 9. Plus, do not forget the constant of integration. So we have the plus c. Another example, let us consider square root of 9x squared minus 16 dx over x. So here, we have a 9x squared minus 16. This is resembling a u squared minus a squared. U squared is 9x squared, while a squared is equal to 16. So a is 4, while u is 3x. If we have a u squared minus a squared, we will be having the form secant. So we have u is equal to a secant theta. So u, which is 3x, is equal to 4 secant theta. Its derivative, so we can have your x equal to 4 over 3 secant theta. So its derivative dx would be 4 over 3 derivative of secant, that would be secant theta tangent theta d theta. We are now ready to plug in x equal to 4 over 3 secant theta and dx equal to 4 over 3 secant theta tangent theta d theta. So we have the square root of, so yung square root of 9 times x, 4 over 3 secant theta squared minus 16. So 4 squared is 16 over 9. So this would cancel out to this one. So what's left would be 16 secant squared theta minus 16. And then we have 4 over 3 secant theta tangent theta d theta all over x. So x is 4 over 3 secant theta. We can cancel out the 4 over 3's and the secant theta. So what's left is, so take note that we can factor out 16 and we have secant squared theta minus 1. So secant squared theta minus 1 is equal to tangent squared theta. So tangent squared theta, and then you have here your tangent theta d theta. Secant squared theta is tangent squared theta. So taking the square root, so we have square root of 16 is 4, and square root of tangent squared theta is tangent theta times tangent theta d theta. So we have tangent squared theta equal to secant squared theta minus 1 d theta. So we have 4 secant squared theta d theta minus 4 d theta. For the integral of secant squared theta is tangent theta, and the integral of d theta is theta. Let's go back to the substitution that 3x is equal to 4 secant theta. So secant theta is 3x over 4. We're going to form a triangle. So secant theta is hypotenuse over adjacent. So the hypotenuse is 3x and the adjacent side is 4. So hypotenuse squared minus adjacent squared, so that would be 9x squared minus 16. Observe that usually the unknown side would be the square root of the a squared minus u squared minus a squared, or the initial form that we eyed into. So we need tangent theta. Tangent is opposite over adjacent. So 4 tangent theta would be 4 times the square root of 9x squared minus 16 all over 4 minus 4. So since secant theta is 3x over 4, so theta is inverse secant of 3x over 4. So we can cancel out 4. So we have square root of 9x squared minus 16 minus 4 arcsecant of 3x over 4 plus c. So that's for the examples regarding trigonometric substitution.